Welcome to What's Next. Every time you turn on a light, press the gas pedal, or charge your phone, you are touching one of the largest and most complex machines ever built by humans. Not a single machine in one place, a global one. We use energy every day, constantly, almost unconsciously, just like breathing. We depend on it for survival, but we rarely stop and ask, where does it really come from? How does it move? And what kind of system is working behind that simple action? When you flip a light switch, you are not just turning on a lamp, you are connecting yourself to power plants, thousands of kilometers of transmission lines, transformers, control systems, markets, and policies, all working together in real time. In this video series, I want to take you inside that hidden world. Welcome to the course, Energy Systems Analysis. In this episode, we will answer two fundamental questions. What exactly is an energy system, and why is understanding its history essential for our future? This course is mainly based on the reference book Energy Systems Engineering, combined with selected parts of my own master's level lecture notes. Let's begin. So, first things first, what do we actually mean by an energy system? Let's split the term into two parts, system and energy. A system, in simple words, is a collection of components that interact with each other to achieve a purpose. Your body is a system. A city is a system. The internet is a system. Each one has inputs, processes, outputs, feedback, and limitations. If one part fails, the whole system feels it. Now, energy. Energy is a measurable quantity that allows us to do work. We can produce it, convert it, transport it, store it, and finally use it. Energy appears in many forms. Mechanical energy when something moves, thermal energy when things heat up, electrical energy in wires, chemical energy in fuels and food, radiant energy from the sun. And here is a key idea. Throughout history, energy has allowed humans to do more work while using less physical effort. At first, humans used their own muscles, then animals. And yes, animals are energy converters. They eat plants, convert chemical energy into mechanical work, and help humans plow fields or transport goods. According to the reference book, an energy system is much more than just electricity. Engineers usually analyze energy in three main domains: electricity, for lighting, electronics, data centers, and modern life; heat, for space heating, industrial furnaces and processes; transportation, fuels that move cars, ships, trucks, and airplanes. An energy system is one of the most complex systems humanity has ever created. So, what do we want from it? First, reliability. We want energy to be available whenever we need it, in the amount we need, at a price we can afford. But today, there is a fourth and critical requirement: environmental sustainability. A system that worked for a few 100 million people no longer works for billions. The pressure on the planet is real. Modern energy systems engineering exists to solve this challenge. Energy systems can be studied from many perspectives: history, technology, optimization, reliability, economics, policy, geography, and even social behavior and culture. And in the upcoming videos, we will explore them all. Now let's rewind time, far back. Energy use has always been tied to human civilization, from animal muscles to burning wood for heat and cooking. Humans gained controlled use of fire roughly 400,000 years ago. That single breakthrough changed everything. Fire meant warmth, protection, cooked food, and longer survival. Let's take a look at how the energy cycle worked throughout history and how the sun is actually the ultimate source of all energy. For over 100,000 years, humans lived more or less like animals. That changed with the cognitive revolution. Back then, solar energy reached Earth as radiation. This energy got stored as biological energy in wild plants. When plant-eating animals consumed those plants, the chemical energy moved from the plants into the animals. This cycle continued, transferring the energy into wild animals and eventually into humans. Humans then converted this energy into kinetic energy, or work. For most of human history, this was the energy cycle. About 10,000 years ago, the agricultural revolution happened. Humans domesticated plants and animals. This upgraded the system. Animals now worked alongside humans. Productivity increased. Civilizations grew. But progress was slow, very slow. Before the year 1800, technological change took centuries. A great example is the windmill. It took thousands of years to evolve from simple vertical designs in the Middle East to advanced rotating towers in the Netherlands. Then came the Industrial Revolution. This was the turning point. Humans discovered how to convert energy into work without passing through plants or animals. Steam power replaced wind and water. Internal combustion engines and electric motors spread everywhere. Trains, cars, and airplanes were born. Energy consumption exploded. To understand the scale, consider this. In 216 BC, during the Battle of Cannae, the total power output of about 100,000 soldiers and 10,000 horses was roughly 9 megawatts. Today, a single modern power plant can generate more than 500 megawatts with only a few dozen workers. After World War II, energy consumption grew at an incredible rate. If we look at the chart of global energy growth, from 1850 to 2000, world population increased about 5 times. Global energy consumption increased about 17 times. This growth can be divided into 4 phases. 1850 to 1900, railways. Energy grew roughly with population. 1900 to 1950, electricity and oil. Energy use began to outpace population. 1950 to 1975, golden growth, cheap energy and mass consumption. 1975 to 2000, efficiency era. Oil crises slowed growth, but it never stopped. Later, the pace of revolutions accelerated. First, the information and communication revolution, then biotechnology and genetics, and from their combination, artificial intelligence emerged. Finally, blockchain entered the picture. All of these depend heavily on energy. Let's summarize. An energy system is an interconnected network that provides electricity, heat, and transportation. For most of history, it evolved slowly, but after 1800, it grew explosively. Today, this massive system faces new challenges: sustainability, climate change, and efficiency. Understanding its history matters because it shows one critical truth. We are deeply dependent on high energy consumption. We cannot simply turn the system off. So we must learn how to analyze it, improve it, and redesign it intelligently. In the next episode, we will explore a fascinating question. Do countries need to consume more energy to become richer? We will examine the relationship between energy consumption, GDP, and the Human Development Index. If you found this video useful, please like it, subscribe, and share it. See you in the next episode.